I'm going to share with you an example of an installation of the Maximum Power Transfer Solution, or MPTS, in a school setting at Flowing Wells High School in Tucson, Arizona. The high school was built in 1954 and has an average electrical load of about 500 kilowatts, which includes HVAC chillers, large air handlers, motors, T8 fluorescent lighting, office equipment, computers, and at the time of installation, the entire school district's data servers. MPTS was installed on one of the electrical service panels, which had the highest load and kilowatt per hour usage. This panel is also supplied by an on-site solar power array, which MPTS enhances.
A lot of the high school's older, and so a lot of old infrastructure, a lot of old electrical conduit and lines.
We had numerous issues. We were losing motors and AC units. We were losing pump motors for our chiller system on the water side. We were losing lighting systems, ballasts. Some ballasts were at different locations were going out 3 or 4 times a week. When I first got here, we were looking about a year to year and a half changing out the pump motors for our chiller systems because they just couldn't function. The system, the energy that was coming in was so horrible. We were losing them. Right now, we've had the MPTS up for about 2.5 years now. Yeah, about 2.5 years. And the same pump motors are still out there pumping since we put the MPTS in. It's taking and cleaning up all of that dirty, rotten utility power that's being created off of generators. Even solar systems that are introducing power back into those grids. It's cleaning it. It's taking that dirty power or unusable power and making it true power. I've been an electrician for 35 years. There's nothing out there that works the way this system does. This thing pays for itself. It really does.
We had a power surge that came through one of the transformers that was running through the MPTS, and I can't remember what the number was, but it was huge, and it knocked out in the MPTS. I believe saved the life of our new chiller. And you know, obviously that acted as a GFI. It took the hit. It protected the chiller, protected going through and further into the school, into other, following the currents down.
During our conversation with Robert, the school experienced an electrical surge, which the MPTS technology absorbed as designed, with no negative impact to the unit or the school's electrical network.
We just took an inrush. That was cool. So we got to see the MPTS at its what it was doing. That would have went somewhere. Where? I don't know, but it would have went somewhere within the school district.
If you dip into the electrical theory a little bit, it makes sense.
KVAR is reactive power that's never going to be used. So when we look at a beer that's being poured into a glass, you look and you see your beer coming up, but you get that white foam that builds on top of it. That's like your KVAR. We are going to get charged that entire consumption of energy from that glass, even though that top portion of foam we don't use. But the utility company sees it coming through. They see it coming through as a kilowatt. So our machine that's sitting behind us here, our leveling MPTS, it has a built-in system into it to where it will take that KVAR and it will take that foam from the beer and it starts reducing it more and more and more and more until all of that's cleaned up. Now it takes all of that and it reintroduces it back into the system as true power. So this portion of this KVAR now is being put back into these loads amps that's on the main system. So that 72.6 is being added in with our 60. So our main current that the utility sees that they think we're using is 60.8. By cleaning this and introducing what our solar that's being cleaned back up as well, we're actually using 111, but our utility only sees that 60-61. Since the MPTS has been put in, we're not changing motors like we were in any of our systems. In our AC systems are lasting longer periods of time. We have very, very old AHUs. Some of them are probably 20 years old. And now they seem to be working more efficiently. The chillers are operating smoothly. You can sit outside of this unit and listen to these chillers come online. And that motor hum, that sounds, that vibration that comes out, it's not there anymore.
I just think that the way the MPTS works by bringing, we should always be economical, we should always try to be more efficient. The fact that it acts as a protector, the fact that it saves our motors, everything runs smoother, easier. We have longevity in our equipment. So, our maintenance team's busy enough without needing to go to a motor in 5 years versus 10, 12, 15, whatever. So I believe it saves us time, money, and everything.
The successful results at Flowing Wells High School illustrate just some of the benefits of the MPTS technology. MPTS is an appropriate standalone solution for any application that requires a reliable and stable electrical network for running high inductive loads, or where sensitive electronics and equipment are at risk from power surges and spikes.